Hello, my name is Mashita and I will explain about the introduction of this experiment, which is properties of fluids. The study of fluids properties is a foundational aspect of fluid mechanics, which is essential for designing and analyzing systems involving liquid or gas flow. Four of the most important fluid properties, which is density, pressure, viscosity, and capillarity, play a crucial role in determining how fluids behave in both static and dynamic conditions. Density affects the mass of fluid in a given volume and influences buoyancy and hydrostatic pressure. Pressure is the force exerted by a fluid per unit area and is a key factor in fluid statics and hydraulics. Viscosity describes a fluid's internal resistance to flow and is critical in determining flow rates and energy losses in pipelines and machinery. Capillarity or capillary action is the result of surface tension and adhesion forces, allowing fluids to move through narrow tubes or porous materials, a phenomenon widely observed in soil mechanics and biological systems. Understanding these fluid properties through experimentation helps students connect theory to practical and equips future engineers with the knowledge needed to solve real-world engineering problems. Moreover, this aligns with Sustainable Development Goal (SDG 9), which is industry, innovation, and infrastructure that emphasize the importance of technology advancement and sustainable system design. Mastery of fluid behavior enable innovation, water resources management, energy system, and resilient infrastructure development. The objective for this experiment is to demonstrate how fluid pressure increases with depth in a static liquid by observing the distance water jets travel from holes at different heights and to relate this observation to the principle of hydrostatic pressure.
Hi, my name is Fatina Nabila and today I will be doing density of fluid experiment. So, first we will go through the apparatus. The apparatus that we are going to use in this experiment is water, few objects, beaker, oil, and dishwasher. Now, we will conduct the experiment. And first, we take the beaker and fill it with water and add some oil and dishwasher. And now, we're going to leave it for 15 minutes. After 15 minutes, we can see that the liquid separate out into different layers because they have different densities. So the dishwasher doesn't mix as it has the highest density. So it sits in the bottom, whereas the oil has the lowest density, hence it rises to the top. Now, let's try to drop. If you drop this marble, which is really dense, and let's try to drop the bottle cap. Finally, I dropped the bottle cap and we can see that it does not exceed the oil, hence it has the lowest density. And the marble drops to the bottom, hence it has the highest density.
Water that have 4 holes inside with 3 centimeter gap. And then we have knife and also water. The observation. Water jets from lower holes travel farther horizontally than those from higher holes. This shows that the deeper the hole, the greater the water pressure, resulting in a stronger and longer reaching stream.
Hello everyone, I'm gonna show you all the apparatus. First, marble, plastic measuring cylinder, oil, water, and dish soap. First, I'm gonna put 3 samples, oil, water, and dish soap in different plastic measuring cylinder. We put all the sample until it reach 80 milliliter. Now, I'm going to take a marble and drop it into the water. Next, we will repeat the experiment using the different samples such as oil and jisoo. After we drop the marble into 3 different liquids, some of them are very quickly moved to the bottom of cylinder, while others move very slowly. This is proved by the result that we have obtained, as we can see from the table result. The time taken is different in every 3 samples of liquid.
Objective of this experiment is to describe how capillarity occurs with different diameter tube is placed in contact with water. So, I will take 2 straws with 2 diameter but with the same length. First, fill beaker with water. Second, put straws into the beaker without touching the bottom of the beaker. Then, stir for about 30 seconds in a beaker that filled with water. Next one, after 30 seconds, we will see the water level in straw are higher than water level in beaker. And the last one, the narrower the diameter of straw, the highest water level in it.
The conclusion of this experiment is to show that fluid pressure increases with depth, proven by how water jets from lower holes travel farther. This principle explains why dams are thicker at the bottom, why water towers supplies pressure, and why divers experience greater pressure underwater. Understanding fluid pressure is essential for designing safe hydraulic structures and everyday systems like water supply networks.